Thanks a lot for being here this morning. It's early. Good morning. My name is Talib. We're going to talk about in-memory data grids today. I'm the founder of Hazelcast. Hazelcast is an in-memory data grid product. It's open source, Apache licensed. I developed the implementation of Java Spaces 9 years ago. If you remember Genie and things like that, it was quite popular back then, and so I got into the space, and since then I'm in love with distributed programming, distributed data distribution. So 4 years ago I started Hazelcast, and now it's being used by many of the big companies. If you're working for a big company, probably some group in your company is already using Hazelcast. So what is a memory data grid? It's for it's like several JVMs sharing data, and then querying the data, observing the changes, executing code on the data, and the grid is using your own data objects. It's not a different type of data. Like it's not like a JSON or just like in the case of JDBC, it's not like columns and tables, rows. It's your own objects. You're storing into the grid, and then processing in the grid, querying, manipulating the data in the grid. So it lives inside the application, or it's closer to the application. It understands the application. It's not like a remote database has a spec, has a strict way of talking to it, or strict data type that you have to use. It's closer to the application. Why? Why do we need that? Because applications do need to share data. For example, in the case of session clustering, session application, for example, or application state sharing. Also, a very common use case would be distributed caching, obviously, for performance. Also, you store data into the grid, and then you parallel process. We see that a lot in financials, doing Monte Carlo simulations, or life sciences, doing a lot of modeling. It's also very good for scalability. As your users increase, number of users increase, you should be able to handle them. You should be able to scale. And very important feature of in-memory data grid is that it can be embeddable. It is embeddable. It can be embedded into your application. This is very good for easy deployment. You don't have your deploy the users of the or deployers of the application doesn't have to set a different cluster and then maintain it. It can be part of the application, and it can start inside the application. Embeddability is very important feature of in-memory data grid. Not all support that, but most of the in-memory data grid solutions do support embedding. So also working with your objects is very easy. You don't have to deal with JSON or any column row type of data. So we do have options, a lot of options in the market. We have Hazelcast, Oracle Coherence, IBM, all the very famous solutions here. Can I see hands of people using Hazelcast? Any Hazelcast user here? How about Oracle Coherence? Okay. Terracotta? Okay. All right. So not all, but most of the products do have partitioning. they partition the data, store into different nodes, and then process on it. So let's say we have 5 million entries and 5 nodes. Usually there will be each node will hold 1 million record and some backup. We have to know that so implementations are quite different, even though we take them as a memory data product, think that they are almost the same. They are quite different in terms of how they partition it and how they back up the data. So sometimes they have dedicated backup servers. Sometimes they have dynamic backup mechanism, like selecting a backup node dynamically. So they are quite different in terms of how they partition and how they take backup. Scalability comes with a cost. It's not free, really. So if you're running a single node application, you have a high throughput, everything is local, obviously all reads and writes are local, you have a good performance. Obviously it's single node, it's not so you want to scale that, but when you start scaling you see something funny. It actually, the throughput will go down because now your reads or writes are also going to the other node, right? So your throughput will go down with the second node, and then we start seeing the linear scaling. And at some point, X is the some point, you're going to catch up with the one node performance when using data grids, and then you'll be able to go up and get better throughput. So still, even though it's linear, how linear, right? So that's also another question. What's the degree of linearness? But eventually we do scale. So what's the X there? It depends on the application and how it's using the data grid. It could be 3 nodes, it could be 5, 10, even 20 nodes to catch up with the one node throughput. So just be aware of that. Common features of data grids, most of them do have, of course, distributed maps, distributed hash tables, and most of them can do caching, right, with the evictions, with the eviction policies. Your entries can expire at some time. Most of the products do provide that. Also, they do have some form of code execution in the grid, in the form of executive service or a map reduce, because that's one of the biggest benefits of data grids, right? We have the data distributed already. We want to process it in parallel. Okay. Also, most of them do have listeners listening for the updates in the caches or maps. Also, querying is a common thing, looking up for the entries with a specific criteria. They do have Hibernate second level cache. Implementations are all different still, but they do provide that integration. Transactions are supported to some degree, like some of them are local, some of them are two-phase commit, but they do provide some level of transaction. And map reduce, map store is also a cache store, or very common, because it's in-memory stuff, right? We want to be able to talk to backend, a data store to persist things, load things, so they all provide some way of storing and loading. So when it comes to deployment, your grid can be a remote cluster and to your application or application cluster. So your application cluster is talking to a remote dedicated data grid cluster. It's good for isolation, very good for isolation. Because you now know that your data grid is using a dedicated heap or memory, a dedicated CPU, and also it's very good for upgrading your applications. Why? imagine this. Since it's a remote server, a remote cluster, upgrading your web applications, right? A lot of times in a day, won't affect the cluster. You're upgrading only the web application layer. The cluster stays the same, so it's not affected by the deployments. A lot of deployments of the upgrades of the application. So it's good. But embedding is also excellent when it comes to deploying or distributing the application, because it's part of the application. It is inside your WAR file or EAR file. As you run that application, will be a node will be starting in that application, and you don't have to deploy or maintain a separate data grid cluster. Your application becomes the data grid cluster, and application and data grid lives together. Also, decision that you will be making will be depending on this amount of data you have. So imagine you're caching hundreds of gigs or even terabytes of data, right? So imagine this, and then you're saying that you wanna, whenever you upgrade your application, you'll be restarting your web app, right? So web Tomcat JVM or WebLogic. Then you don't want this data to be shuffling around. So if it is remote cluster, then data stays there, nothing changes, data is still there, your application just getting upgraded. So if it is embedded, then this gigabytes of data will be going down, and migration will happen. So the amount of data will also should guide you when choosing whether it should be a remote or embedded. We see both of them a lot. So sometimes, like they even run on the same box. They run web app and the data grid node next to it on a separate JVM. Okay, so that way, from the web app, you're connecting to a local grid member. And it's sitting on a different JVM, so it's using it has its own heap, and it's connecting to the grid as a client. So that's also a very common deployment. So in terms of caching behavior, we see cache aside and cache managed. Cache aside means the cache and the database are separated, and you manage that. The developer will be talking to both of them. So the developer, the code will be going to the cache first. If the entry is there, we'll be using it. Otherwise, it will go to the database, fetch the data, put it into the cache, so that next time you can read from the cache. This is caching aside. And cache manage is more like you're only talking to the cache, and cache manage is talking to your data store. So read through means if the record is not in the cache, load it from the database and put it into your cache. Write through for the updates for storing. Write through means right behind. Write through means when I'm doing the put, I want to make sure that the store invoked as part of the put operation, and my record is also in the database when the put returns. So right behind means I want to put it into the cache and mark it as a dirty record, so that every 5-10 seconds it's configurable. The process will flash all the dirty records to the data store database. So of course, for consistency, write through is awesome, but for performance, write behind is very good. Even with the case of write behind, like assume that you have a database and you're using write behind, and your database goes down for some minutes. If the data in the memory is good enough for the request coming in, you won't even notice that database is down, because you can serve from the memory. It's not tied to the database. So the database can go down for some time, but when it comes back up, since it is right behind, it will flash all the updates happen during that period. So it's very good. But of course, you're losing some consistency, or if there's a failure, big failure happening then you might lose some of the data because it's stored in memory, but not in the disk database yet. It scales amazingly well, way better than write-through, of course, and latencies are very low. So when caching a site, then you should consider invalidating the cache on updates so that you can have a higher level of consistency, because caching a site creates inconsistency. You can go out of sync, your cache and database can go out of sync when you're using cache aside strategy. So invalidating the cache on update will increase the level of consistency, but still not guaranteeing you the perfect consistency. So sometimes, most of the products do provide a near cache, meaning everything is in data grid, but you can locally cache that so that you don't have to go to the grid. Even you don't have to go to the grid for every read. But anytime we talk about caches, we talk about consistency problems. Your cache might not be that up to date. So always consider invalidating on update for higher consistency. But if your update rates are very high, then you might kill the cluster, because invalidation is also very costly, right? So if your updates are very high, try to use TTL based near caching. That's a lot better. Optimize serialization. Serialization is the biggest, probably the biggest cost in the whole thing. Okay, it's the biggest performance killer. So try to use custom serialization that's provided by the product itself, and most of them do provide a custom way of serializing your objects. And storage, also note that storage, the way the data is stored in the grid will be different depending on the product. Some of them will store as an object, some of them will store as a byte array, and just don't have the wrong feeling that it's going to be object all the time. Don't get that feeling. But they do have good reasons for that, storing as a binary or storing as an object. Some of them do provide doing both, meaning storing both byte array plus object next to it, so that if there's a query will read the object directly. It doesn't have to deserialize. But if it is reading from the remote machine, then it will write the byte array directly through the wire. So they both have good use cases. But just know that they are different. Don't get a wrong feeling about it. Always know the cost, even feel it. Like when you're writing map dot or cache dot something, try to feel what the cost is. For example, map.get is very cheap. Why? Because it's one network call. But on the other hand, map values with a predicate or a filter will go to all nodes doing parallel query and bringing results back. So obviously it's way costly, and even though we have great features in every data grid, we will love to use queries, listeners, and all that stuff. It's good to use, but you have to know the cost and make sure that the cost is not higher than the benefit itself. Listeners are good, but it's still a little dangerous because it creates a lot of network calls if you're listening a lot, and updates are very high. And always good to use things like put all to optimize things. So putting in once and using atomic operations like put if absent, always good, always good. These are optimized calls. So try to when you do, as just like you do when you write a SQL application, right, database application, you do get the feeling of the SQL statement, like how the select will work, how costly that is. So we have to get the same feeling from when we are writing distributed stuff. So when you do cache out something, just try to predict the cost. They're not complicated though. Like when you read the documentation and you understand how the product works. At some point, you definitely do get the cost of each operation. It's not something magical or something that's hard to learn. Be careful about the Hibernate second level cache. Because if the objects that you're caching or using with Hibernate are very complex, then lazy fetching might kill you if you're using a second level cache, because each object in the hierarchy will be calling a cache to get the value. So eventually you might be calling 20, 50 cache call to create the object, complex object. So it may cost way more than just reading from the database. So just be careful. We got better performance for some of our customers to use cache aside instead. If you can enable near cache, it might help, but cache aside might be also a very good strategy here. So first, the rule of distributed computing is do not distribute, of course. So try to stay local if you can. Even cache things for 5 seconds. 5 seconds might be a very little time for a human, but it's a very, very long time for a computer. I'm not saying it's always possible, but if it is possible, consider caching even for 5 seconds. And also for all the operations that we're going to be doing, so we should try to look for a way of localizing the operations. Even like when we are near caching, what's the purpose of near caching? It's of course localizing the thing, right? So or when we are executing code on the grid, what's the purpose of executing on the grid? Because we want to localize the calls there. We want to go to the node, execute the code next to the data so that things can be local. So a lot of the things that we're going to be seeing are going to be related to the do not distribute principle. So very common thing, if you have a cache, keys are distributed. So you look for the API that has similar semantic, like execute something on the key. These are optimized. Why? Because you don't. This way you don't have to. You can get away with. You don't have to lock the key for executing that thing, and also the data will be local to you. Execute there. So try to look for APIs like that. Try to execute next to the data and avoid locking. These are going to be guaranteeing. These are going to be giving you implicit lock on the key, anyways. So also, how are we going to store our data? What's the way of storing it? So one normalized way that we all know from the relational database world. So customer is a customer, order is totally separate. There's a foreign key relation, right? So then for the in-memory database stuff, we will have customers and orders data maps, right, or caches separately, and we're managing these two caches separately. So this is good when you're looking or reading the orders by key, for example. But what if you're looking for? What if you need is a is the orders of the customer. So getting the orders of the customer in this case will be very, very hard because they are kept separately. There has to be a way of knowing which key orders belong to which customers, right? So so this is good when you're reading things separately, but it's bad when these are very related and you're executing order customer and orders together most of the time. So even if you have to do this, you still have to at least make sure that orders and the customers are staying on the same node. Since they have different keys, they probably will end up on different nodes, right? Your customer will be on this node, your orders are going to be spread across the other nodes. So it's still a lot of network code to even collect them all together, right? So for those cases, so most of the products will have data affinity feature. Try to utilize that. So for example here, order key will have a will be partition aware, meaning and it implements something like partition aware. It will be different, of course, for product to product, but something similar. And it tells you that partition key is the customer key actually. So that way your orders and the customers are going to be sitting on the same node. Okay. Denormalization also important. So most of the time we're going to see this one. Orders are going to be inside the customer object stored together. So in this case, when you get the customer, right, so see there's only customers map, there's no orders map, so customer orders are inside the customers already. So when you do a get on the customers grid, you get the customers with the orders, everything is together, there's nothing to like worry about like the foreign keys and blah blah. But what's bad about this one is that what if you can have thousands of orders per customer? Then like when you get the customer, you're getting a giant object back, or when you're updating an order, removing or adding something, it's gonna it's gonna cost more. So there's no like you have to go this way or that way thing. It depends on the application. So you have to look for the biggest problem in your app. So if your biggest problem is adding this order into your app, then you might probably gonna go with normalized version, because adding orders in the normalized way is simpler. But if execution of customers together with the orders is the biggest problem, then you're probably gonna go with the normalized way that we just saw. We can also, I mean, you might have to even go mixed. So you might want to have a normalized version of it and denormalized. So actually the principles are very similar to the NoSQL world. How you store things in NoSQL is very similar. So because same challenges there. So when you're coding, try to code code as a service. Don't give like the API to your developers and write data grid calls everywhere in your application. It will create a mess and you won't be able to manage after some time. It's a very good practice to have a data grid service written by a very experienced developer, knows the product and things like that, and do not expose the data grid to all developers. Have them as a service to other developers, and that way you know exactly where data grid calls are done, and who wrote that, how it is written. Everything is in one package or one service. Make it more durable, because you will definitely need that. Like things like when there's a problem in your application, like the degradation of the performance or anything, you should. So if there's no idea, like if the code is everywhere, there is no way to log things and figure out where the problem is. But if you make it as a service, then you can have like JMX monitoring or even your own metrics to monitor how long this specific service took, what's the average time it took, and things like that. And also log things like latency is higher than 5 seconds, 10 seconds, whatever it is. Like so it's a good way of coding it. This is not, of course, not related to a product, but it's a very good practice to separate the coding and making it a service. So thank you for listening. We have a booth at 5105. I kept the presentation relatively small so that we can have more discussions. Any question? Yes. What? Which one? Second, what was the question again? Okay. Hibernate is also a data grid itself. Excuse me.
Can you use the mic and repeat the question, please?
Okay. So he asked how the data grid is better than coherence, right? That was the question, right? So coherence is another product. So it's one of the data grids itself. So they have the same things that we discussed. So it's just another data grid product. We cannot say like it's not like data grid versus coherence. Coherence is a data grid.
I guess
So.
what makes your product stand out?
All right. The talk is more about the how we should use it, but is it a good? I mean, who wants to hear that? All right. Okay. First of all of these products that I mentioned, I'm a big fan of them. I try not to say anything bad about them. But what I can say about us is that first, we are open source. We have a community behind us. We have very good number of users testing it and giving feedbacks. We have other data types like multi-map, distributed queue, topics. Also, we have elastic memory, something that allows you to store everything off the heap to avoid GC. So feature-wise, we are different. We have some extras. Of course, coherence do have some extras too. I think we also see a pattern. Should I say that? No, I shouldn't say that. All right, so I think you should try both and see which works for your application better. But in terms of feature set and performance, we are quite confident.
Do you implement a lot of these?
Oh yeah.
That you just mentioned, like data affinity and all those?
Yes. Coherence also does.
Remember that slide that you had regarding all the features across most of the data grid?
Yes.
Is there anything you have later on follow up or something that you can put together for the three products like coherence, class, and other like that?
Sure. I mean, for
Just features. Is there anything like that?
so I could say something like Terracotta is a little different than the remaining others. Why? Because it has a client-server architecture. Even in their documentation, they say we're not data grid. So, but I just wanted to be fair to everybody. Just want to put the names in case they don't. I don't want them to complain that I made a discrimination or something. But the others do have quite the similar features. But implementations, that's what I'm saying. That's the point. Very different. Like some of them have like asynchronous backup by default, and you don't know, and then you're comparing the products, and then the one product is faster than the other, it's not true, but because the backup strategy is by default asynchronous. I think okay. Let me tell you this at least. When you're comparing products, I think the biggest thing will be the biggest differentiator will be how well they handle the exceptional cases, edge cases. So I don't think it's of course you have to know the details of the product to figure out. I mean, when you're prototyping, you should be fair to all the products, right? So if it is a synchronous backup and if the other one is asynchronous, obviously there's something funky there. But that's not even the thing. The most important thing is how well they can handle things like network partitioning. That's a tough problem to solve. Something happened in the network. Things. I mean, partial failures are worst things in the data grids. Worst things. If something goes down, like machine goes down, it's a good thing. There's nothing wrong with that. But it's something like if the kernel panics, that's tough. Okay, it's a partial failure. Or like a GC, right? GC is one of the biggest problems in our world. So long GCs are gonna. So when you're evaluating the products, make sure you look at the edge cases. The other ones are easy. Okay, very very easy. The feature sets, sure, they can do similar things. And talk to them. Talk to the guys implementing it. Just like we have the common feeling that they're doing things similar, but they're not. They're definitely not doing it similar. Like as I said, like backup strategy, they're all different. So how come? So when comparing like Gigaspaces, for example, has you have to set a backup server for a given node. So it's not like Coherence or Hazelcast that we are doing a dynamic backup. So products are different, but they still shine when it comes. I mean, you should make the decision based on how well they can handle the edge cases. And we are all running on a network, and network is very, very slippery. So things are going to go bad at bad times. And how well they can handle these cases, I think that's the most important thing.
The graph that you showed, where as soon as you start scaling, you see a dip. If you see that kind of behavior, is there some obvious things that you can look at that you're doing wrong in terms of how you define it?
I think there's. I mean, if your app is heavily depending on the data grid, there's nothing much you can do because it will happen regardless. You can enable near caching and all that stuff to make it faster, but when you're using near cache kind of stuff, you're giving up on from the consistency, right? So if you can live with that, sure, you try to have near cache and things like that. But if you're not using near cache, there's nothing you can do because there's a network, right? You have to do a network call to get the thing or put the thing. So yes. I think you should deploy it. You don't lose data is not the biggest problem, but imagine you have big data and you're just shutting down the data grid node. Then this data will be owned by others, and then the backups are going to be taken again. There are a lot of data shuffling will happen, right? So that's, and also you're starting again, then again another migration to the new node.
But during that time, you have inconsistent combinations where one node has old code, one node has new code.
So if you're changing your code a lot, deploying the data grid as a separate component will be a better way. So you have here's a data grid cluster, and then your apps are going to be sitting here, and then your apps are going to be client to the data grid. So you're going to be using a client call to the grid. So this way you can update your applications as many times as you like. But if you're asking if the class itself changed, right? So it's you change a customer class, right? Then it's the new classes are not there. So you're getting no class definition or things like that. Unfortunately, since we rely on serialization, there's one trick that you can do, but it's a trick. So the common thing we see is rebooting the cluster. So you deploy the new code and reboot the cluster. Not a nice thing, I know, but since we rely on the serialization, that's what happens. There's one trick that you can do, but still it's a trick that I don't even want to recommend much. So one, I mean, you can implement something like version aware, and then the Hazel class will tell you when deserializing will tell you, hey, here's the byte array, and so it has the. And in your custom serialization, you say, hey, this is the version, so I have to serialize this way. But after 5, 10 version, you're going to go out of sync anyway, so you won't be able to keep up with the which version does which one. So it's good for a couple of versions, but after that, it's going to create more mass. So I don't. But if you do this, like, so if you want to. If you write everything as a byte array, of course you don't have that problem, right? So just like in the case of Memcache, right? So you write everything as a byte array. Everything is stored a byte array in the data grid. Data grid doesn't know any of your classes at all. You do this deserialization on the web server cluster. So then, but you still have the problem of upgrading your web application, right? So because web nodes can have different version of the code. So it's not a problem of data grids. I think it's a problem of serialization in cluster, in any cluster. So because one node has the latest version of the object, writing it, and then the other one is getting the byte array and deserializing, and it cannot because this class is not deployed yet. So I think the question should be, forget the data grids. How can I write that? Yeah, you got it. Yeah, we do support. We do. What's we? Hazelcast, right? So we started talking about Hazelcast. I'm sorry. We support REST, Memcache directly. You don't have to deploy anything to get Memcache support. Our socket can talk HTTP directly, Memcache directly, and our own binary format. Hazelcast doesn't use things like JGroups or any other library. It's all homegrown. For discovery, we use multicast. We use TCP/IP. Also, we use, if you're running on Amazon EC2, you can use Amazon EC2 discovery mechanism. It's built into Hazelcast already. But after the discovery, everything is TCP/IP. We don't talk multicast after the discovery. Yes. When a new node starts, so one guy, the senior guy in the cluster, will make a decision to which partition to migrate to the new one. Okay, and then migration will start. So some of the code will be moving to the new guy. Okay, and then so it takes time, of course. It's like 20 minutes or so to totally get equal again. And then when a node dies, Again, so the backups will be owning the data, and then taking the backups of the lost partitions. So migration will happen most of the time when a new node is added, and of course to avoid the cost of migration, we have to adjust the partition count so that the partitions are small enough to migrate very fast.
But in case of failures, if you have an advanced different situation, if it eventually merges
Oh,
again.
I'm sorry. You're talking about the failure in the. Okay. So Hazelcast will.
It's a suggested work case.
Okay. Yeah. So when a network partitions, it's a bad thing. You're already. So we have to all accept that something wrong in the network, and it's not really a problem of the data grid, but still it has to be able to deal with it, right? So when the network problem is fixed, your two separate clusters should be merging, right? So how are we going to merge, right? So Hazelcast will detect that, hey, I was actually a part of a bigger cluster, but somehow something happened and I look separate. I stay separate, so I have to merge. So smaller cluster will be merging to the bigger cluster. So when merging, of course, they have to merge the data too. So and as you can imagine, same data can be updated, might be updated on both clusters. So we have to resolve the conflict, right? So in the map definition of Hazelcast, there's a section called merge policy. You can use this given provided merge policies, but you can also write your own merge policy. And we're going to give you the entries, both entries, with the hit count, last updated times, and timestamps, and things like that, plus the key and values, and you make a decision.
Oh, that's fantastic.
Yeah. Hazelcast is one single jar, and it's already OSGI ready. So you can put the Hazelcast jar into a OSGI container. And we'll, not sure. Let's talk again later. I'll have to investigate.
How do you handle object versioning? Or is it up to the developer?
It's up to the developer. Yes, they're not. So to us, it's still the same problem, right? That you're changing the class. Yeah. And I don't think there's a magical, very excellent answer to that. It's the same problem in any NoSQL, even like schemaless data, NoSQL stuff do have the problem. Like if the application depends on a field attribute and the attribute is gone, what's going to happen? So adding this might be a little easier, right? So you don't handle that new one, but if what you require is removed, then you're screwed. Yes?
If you have some partial tracing, one of the JVM's tracing because JVM or IY, then the whole cluster stacks actually.
Yeah.
What happens? I tried to Oracle grades, I tried Terracotta to see if I could have a better strategy or something to say about this issue, because it's the worst thing happening to me.
Okay, so yeah, I mean, I understand. I mean, coherence or terracotta. I mean, first, as I said, I mean, what the data grids are trying to live like a single body, right? So like, so every part of the body depends on each other. So even like your speed will be depending on the slowest guy in the grid, right? So So there are things that are, I mean, normal, I should say, like normal to any data grid solution. So it's not a fault, it might not be a fault of coherence or terracotta, so because there are common problems, like your application having a GC problem, right? So it's your application, it's your fault, I mean, not your, I don't want to say your fault, but your application's fault, okay? So, and you're creating a lot of GC issues, and then you expect data grid to, but as I said with the network partitioning, we should be able to at least deal with it, right? So one of the things might be telling you that something is wrong, right? So something like, I should be able to tell you, hey, we got out of memory exception. Do you want to do something about it? Maybe like if I can tell you, maybe you're going to take this server down. You're going to exit the JVM, and because getting an out of memory error will create the problem that you described. So one guy's having a big problem. Others are stuck because of that guy, right? So killing that guy might be a very good solution, because when it's gone, everything will be smooth. But at least we have to be able to tell you, right? Tell you that something is wrong with that node. Hazelcat can tell you that we got exception. Do you want to do something about it? It's part of the API, but still. Also, the applications and the operation guy's responsibility is to monitor the JC, the machine health of the machine, all that, and take the actions sometimes manually, right? So sometimes they're not really. I mean, if it is like a long JC, right? So what can a grid can? What do you expect grid to do, right? It's a long JC.
I'm slow.
Kick me out. What? Well, how do I make that decision? Like, do you want me to make the decision and just remove me from the cluster? Maybe if I can tell you, maybe you're gonna kick yourself out. I don't want to kick you out, but maybe you can say, hey, I got the exception. Let's detach that node from the cluster, right? So maybe that's why we didn't want to do this. Like we used to have that. We used to restart on out of memory, and some other people complained like, maybe it's my problem and I can't fix it. Why do you restart the node? I'll fix it. I can manage my memory and get off the garbage. Okay, then we're gonna give you the interface, and you're gonna handle what you should do in the case of out of memory. So giving the interface hook is a better strategy, and we do provide that. And still, I should, yeah.